2 or 3 independent compartments by longitudinal bulkheads. The tanks are numbered with tank 1 being the forwardmost. Longitudinal bulkheads may be plain or horizontally corrugated. Centerline longitudinal bulkheads may also be vertically corrugated. Transverse oil-tight bulkheads may be plain or with corrugations arranged horizontally or vertically. For crude oil and refined oil tankers, the coatings primarily aim to prevent rust and corrosion in cargo tanks. In certain cases, applying approved coatings allows for the reduction of steel thickness, ensuring the longevity of the ship while preventing premature deterioration. The cargo tank ventilators are to be entirely separate from air pipes from other compartments of the tanker, and positioned so that flammable vapor emissions cannot be admitted to other spaces or areas containing any source of ignition. The pipes leading from the cargo tanks to the pumps are termed as bottom lines. The lines from the pump room up to the deck are called risers. The lines on deck are termed as deck lines. The lines which lead from the deck to the tanks are called drop lines. Inside the cargo tanks, the pipes terminate in a bell mouth. A tank may have 2 bell mouths, one main and one smaller stripper bell mouth. Alternatively, one bell mouth may serve the purpose of main as well as stripping discharge. On most tankers, the main cargo pumps are centrifugal pumps, located at the bottom of a pump room at the after end of the cargo tanks. These may have rated capacities of 1,000 cubic meters per hour on medium-sized tankers. These are powered by a drive shaft from a turbine or electric motor located in the engine room. The direct line system consists of lines running longitudinally in the center tanks and branching out to bell mouths in the center and wing tanks. The system is uncomplicated and found on some crude carriers. The advantages are that it is easy to operate and less training of personnel is required, as there are fewer valves. It takes less time to set up the valve system before commencing a cargo operation. Contamination is unlikely, as it is easy to isolate each section. The disadvantages are that the layout is not versatile, which makes it difficult to plan, especially for multigrade cargoes. The ring main system is also called the circular system. This type of piping system provides for the handling of several different types of oil. A particular tank can be pumped out either by a direct suction line, or through another line by use of a crossover. This system is very versatile. Any pipelines in the tank are taking up space that could be used for cargo. Much of tankers' cargo pipework is on deck. On tankers designed to carry multiple grades of cargo, the pipes can look like spaghetti. All of these pipes have a purpose, and you should know them. On deck, the pipes terminate in a cargo manifold. A manifold may have 2 or more cargo lines. The discharge lines come up from the pump room and connect to the manifold on deck. Tankers do not load through the pump room. There are loading lines on deck between the manifold and the tank lines. These are the drop lines mentioned earlier. Slop tanks are designed to store the residual oil and sludge generated during the cleaning of cargo tanks. Tankers are able to pump the residual oil and sludge to shore reception facilities. There is usually lines on deck and a connection at the manifold to allow this. The purpose of the vapor return system is to ensure that cargo vapors are not released to the atmosphere. Vapor return lines on tankers are either connected to the vessel's PV line or, if the vessel is fitted with an inert gas system, to an extension of that system. The vapor return lines are led to the manifold where a connection is provided to connect to the shore vapor line. Inert gas is the gas that contains insufficient oxygen, normally less than 8%, to suppress the combustion of flammable hydrocarbon gases. Inert gas is the flue gas generated from the ship's boiler. The high-temperature gas mixture from the boiler uptake is treated in an inert gas plant which cleans, cools, and supplies the inert gas to the individual tanks via PV valves and breakers, to ensure the safety of the tank structure and atmosphere. The IG system is connected, on deck via various safety devices, to the venting lines and vapor manifold. Most crude oil tankers have a common cargo tank venting and inert gas main pipeline which is also used for vapor emission control. Branches to each cargo tank are provided with isolation valves and blanking arrangements. If the ship has fixed tank washing equipment, whether for crude oil washing or water, the associated pipework will be on deck. Tankers that carry heavier oils are fitted with heating coils inside the tank. The steam lines originate in the boiler room and pass up the deck to the tanks. Level and pressure instrumentation for ships is crucial for ensuring safe and efficient operation. These instruments help in monitoring the level and pressure of liquids in cargo tanks. By accurately measuring the level, these instruments prevent overfilling or underfilling of tanks. Pressure instruments read the pressure created by the weight of the liquid in the tank through a penetration in the tank wall. Every cargo tank must be fitted with at least one liquid level gauge. The float gauge is widely used in all tanker work and consists of a float attached by a tape to an indicating device which can be arranged for local or remote readout. Float-based systems use a float that rises or falls with the liquid level, providing a visual indication or electronic signal. These often come with a float switch for better accuracy. Radar gauges utilize microwave radar signals to determine the liquid level by measuring the time it takes for the signal to bounce back from the liquid surface. Capacitance-based systems measure the change in capacitance between two electrodes as the liquid level changes. The capacitance gauges measure the change in electrical capacitance between two probes as cargo liquid rather than vapor takes up the space between them. There are handheld gauges which are used through ports in the tank, but these can allow the release of small volumes of liquid or vapor when in use. There are differential pressure gauges which operate on the pressure differential between liquid and vapor. Pressure transmitter systems use pressure sensors to measure the hydrostatic pressure at the bottom of the tank, which is proportional to the liquid level. The connections for the instrumentation pass through pipes for safety. Many tankers have diesel oil and heavy oil bunkering connections near to the cargo manifold. There will be the piping for carrying the oil to the fuel tanks. Some tankers use a separate pump and lines to drain or strip the last puddle of cargo from the tanks. The associated pipelines for stripping pass on deck. If your tanker has a deck crane, mooring winches on the main deck or some types of valve actuators, there will be hydraulic lines on deck. Tankers avoid using electrical tools in hazardous areas. Pneumatic tools are preferred. There will be a compressed air line on deck. The piping for the fire water system passes on deck.